Eli, Mystic Circuits, great to meet you. Superbooth 2018. How's it going?
Perfect, wonderful, having a great time.
Stand looks great.
Thank you.
Sounds great. I believe Codec from America's been by, some next level rhythmic degradation and synth destroying action.
Yes, intense beats follow him wherever he goes, and he was gracious enough to bless us with the gift of Gabber.
So, I mean, let's have a look at the modules. What's going on in this patch, or we can hear them on their own?
Sure. What's going on in this particular patch is a combination of the vert on gate sequencing. Vert will take a signal in and generates 8 gates based on the value of your signal. Those two of those gates are controlling the pico drum, which is going into the portal, which is an upcoming distortion module from Mystic Circuits.
Is that the kind of real magic of the patch at the minute?
Yes, you're hearing the sequencing and the drums are all pico, but the thing that's making it sound that intense, bubbly squelch is all coming from the portal. And I've actually never gotten it to make this sound before, but Codec managed to do some crazy stuff, which made it real wild. The portal's nice because it has 3 different kinds of distortion, which are all different outputs, so they're simultaneously available. It works with a technology known as wave wrapping, which is similar to a wave folder, but much harsher. And this particular circuit works with feedback, so instead of stages where you only get 3 or 4 folds, 9 folds usually is the typical amount, this gives you something like 100 wraps, which means that you can put an envelope or an LFO through, it'll make weird, bubbly kind of squeals.
Is that what we're seeing on the Mordax data at the minute, the input and the output waves?
Sort of. The red is actually coming from another module, but the green is in fact, actually let me do that. Yeah, so the green is the output of the portal. It's not going to make any sense with what's going on right now, but let's take a look at what's going on here. So we have, I believe we are listening to the spike output. Yes. Spike will just generate a bunch of spikes whenever a harmonic is made. It's a little tough to understand without first looking at wrap. So wrap is the main function of this module. Basically, it's what generates the harmonics. The wrap amount decides the amount of harmonics that are made. The tracking controls how well they're made, and that goes all the way down to 0 for silence. And then
is that almost like a really intense noise gate? Most things will be cut out almost when it's just above silence?
Yeah, I mean,
or
you
it'll
can
generate less.
Yes, so
spikes.
like definitely there's a sort of sweet spot right around silence where it'll generate less spikes. It's the range is very sensitive though, so I wouldn't think of it as a noise gate exactly, but it definitely does affect the sound in an interesting, unpredictable sort of way. There's also this voltage controlled feedback, because of course everything I make needs feedback. The wrap and tracking have a really strong influence on that. And then the bias control will help to introduce some of the original signal back in, which brings back in some of the bass frequencies. It might be a little easier if I just plug an oscillator in. This is plates.
Plats as in platitaire, although I don't think you say platitaire in the US.
As in platypus. It's the platypus oscillator going in, and you can sort of get an idea of what it's doing to some just static tone. Feedback obviously has a strong effect, and then we do some of this. You can hear the distortion. The next output is round, which is much quieter, but basically it sort of acts like a bit crusher in that you are making little stair steps out of your input signal. So this is pretty similar to the input signal. It's a sine wave, and then slowly move down, got these little stair steps.
Yeah, you can hear that familiar crushed kind of bit of fuzz on top.
Yeah, it's much more subtle than rap, for sure. But yeah, it's got the little bit of crispiness. It's nice being analog. You can get all these places sort of in between something that would normally be digital. And then, of course, track and feedback and bias all have an effect on the signal as well. With something a little bit more harmonically interesting, it might give you a better idea of what the effect actually sounds like. Yeah, and then we were listening to Spike at the beginning, which basically gives you a spike every time a harmonic is generated. And that reacts quite a bit to the tracking control as well as bias and feedback.
It's almost like a hybrid noise source at that level of modulation.
Yes, definitely. You put audio in and noise is what comes out.
In various colors.
Exactly, yes.
We should also mention, I have a few videos on these, the 0 HP. We've got some new filters, there's a low pass gate.
Yes, so we have already released the low pass filter. It works at audio rate modulation and also features a clipping circuit, which I added in order to sort of emulate resonance in a circuit where resonance can't exactly be used, so it helps add some grit to the sound. Next up is a band pass and high pass version of the filter. The high pass is somewhere else around here, or else I'd show it. The newest module that we're working on right now is an envelope follower, so you can put audio through and it'll generate two control voltages based on the amplitude of the audio, one that goes fast and another one that goes slow. So you can extract envelopes out of drums or samples or just different things going on in the patch. You could also plug gates in and they just work as static decay envelopes. And also the next thing we have coming up, which is further off, but we have an envelope slew sort of module, which would be rise, fall, both being voltage controlled. And the idea that I'm kind of aiming for is that you can have it with no control voltage plugged in. You just plug a gate in and you will get a decay envelope out of it.
Okay, cool. So roughly how far off are the modules and the 0 HP stuff?
So actually I have two modules. Portal's a way off. Since I have two other modules which are coming out first. The envelope follower, I plan on ordering boards probably as soon as I get back to the States.
Okay, cool.
Then I have two modules which are currently entering production prototyping with WMD, and those will be beta tested soon as well. I can show those to you if you like.
Yeah, let's check those out.
Yeah, so some of you might know I make the only other module besides the Turing machine which can use Turing machine expanders. This is the second one that can use Turing machine expanders, and it's called the Tree. It is a sequential switch. You'll notice here we're running a clock in. It's making pretty much the kind of behavior that you would expect. The light that's tracing down is also linked to the voltages expander, so you can use it as a note sequencer. The common input-output is tied to a positive voltage, so that you can use these as gates when nothing's plugged in here. What sets this apart is that there are these shift inputs at the bottom. So if I plug into shift by 4, you'll notice that the active step is jumping around a bit. It's still influenced by the clock, but if we unplug that, you'll see it shifts by 4. Shifting.
So by using different rhythms to jump and to actually step through, you could get quite creative with just 8 steps.
Absolutely, yeah. It's not really an 8-step. I mean, it can be used as an 8-step sequencer, but once you put in gates that are in other time signatures or other clock divisions, you get all kinds of evolving rhythms out of it that are longer than 8 steps, hypothetically. So you can use all 3 of these shift inputs simultaneously. And that's unplugged. We're reaching the point in the day where the patches no longer make sense. If you plug into all 3 bits, you get all 8 steps with the combination of which ones are on or off. You can also use the clock input in order to rotate the selection of bits, and this will give you some very interesting evolving patterns. You get the note sequencing with voltages, bidirectional sequential switching in normal operation, and then with nothing plugged in here, you get a gate sequencer. So a lot of bang for your buck as far as size goes, And yeah, that's Anna. Or I'm sorry, that's Tree. Anna's the other module that's coming out soon. And I believe that's the one that's plugged into the scope. So if we do... Just making sure I know what the heck's actually going on before I try to explain it to you.
Yeah, demoing stuff that several hundred trade show users have had their hands on is not ideal.
Well, I'm the worst user of all, so here we go. What we have here, one more plug. And undo the modulation, of course. Okay, so Anna is more or less, actually I'm going to probably do a simpler oscillator as the main one. Okay, Anna is an analog logic module. So some of you might know that analog logic, you can use what's known as a minimum in order to emulate a logical AND gate, but it will work with continuous voltages. So you can see here the blue and green are our inputs. I'm trying to get it in a place where it stops moving around so much. There we go. And you'll see that the red kind of traces along whichever voltage is the lowest of the two. Now max traces along whichever one is the highest of the two, the maximum. Now, I used this logic to sort of make a combination of different functions. So this would be the XOR of the two voltage signals. It ends up acting like more or less a bipolar VCA. So if we do some of this, you get ring mod kind of sounds. The magnitude is the difference between the maximum and minimum. So you get a difference rectifier, and that gives you a positive voltage all the time.
Quite a different tone to the ring mod.
Yes, they all have a little bit of a different flavor. Obviously, the minimum and maximum are the most similar, but the ring mod and the magnitude is almost more like it's sort of like a wave folder, because you can get octave doubling sorts of effects, but it's rectifying the subtraction of the two signals, if you really must know how it works. Step is a track and hold of the two signals. So that will give you kind of smooth step generator shapes. So you can see here, sometimes the signal going through is wavy, and sometimes it's being held at a static voltage. So you can get some very strange sorts of wave shapes out of that. It'll also give you downsampling sort of effects, because I'm addicted to that. And yeah, it's really useful for sending in LFOs and getting something similar to a note sequence coming out of that. The last output is called box, and it's the loudest. It's a bipolar comparator. So if I was to unplug one of these, you can see, maybe I'll go with the other one. You can see we have a square wave with 3 values. So there's the high wave, the low wave, and 0. If we change the offset on the second channel, you get some interesting pulse wave.
So it's almost like pulse width modulation around the 0 point.
Exactly. There's pulse width modulation of both the positive and negative portion of the wave. So if you put an LFO in, you get some nice shapes coming out of that. Another thing to point out is that these knobs can act either as an attenuverter or as an offset. So you plug in here, this knob is now an offset. You plug in here.
Oh, that's nice that you actually get both.
Yes, and you can use all the inputs simultaneously. So technically you can process 4 things, but really, ideally, you can just put one thing in and you get 6 strange wave shapes out. And they're very responsive to the knob. So you can have 6 things coming out controlling your patch. You change one knob, it changes the entire behavior of the patch.
So how far out, Anna, is that one you said is going into production?
We're doing prototyping now, production prototyping. So I expect to be either Tree or Anna. Hopefully both of them will go into production this summer. But I expect that at least one of them will be working well enough to start production once I get back home.
Okay, thank you very much.
Thank you.